Hey guys, today we're going to be talking about logarithms. A logarithm is the inverse of an exponential function. So what that means is you have learned inverses such as addition and subtraction are inverses, multiplication and division, square rooting and squaring, things like that. One undoes the other. Well, a logarithm is what undoes an exponential function. So logarithm and exponents are inverses. So I want to show you. Let's say we have x to the y power equals z. I'm just using x, y, and z. We'll get to numbers in a second. How you would rewrite this, so notice this is an exponent. It has an exponent of y. You would rewrite it as log base x of z equals y. And so there's different parts here. This number here is your base, and so it comes down here to be the base of the log. Here's your exponent, and it gets moved over here. And this one here is called your argument. So you have base, exponent, and argument, and those rearrange when you're writing exponents and logs. So I'll show you how we rearrange them using numbers. Oh, I want to put this in first. This is how you always read it. So log base, whatever your number is, of whatever that number is, equals whatever that number is. This is how you read a log, okay? So now we'll do a couple examples. So these are all exponents right now, and we are going to rewrite them as logs. So it is always log. Whatever your base is, which in this one's 2, your base stays first. It's always going to be the first number. So it's the first number of your exponent, it is the first number of your log. So log base 2. And then the second number switch of 8 equals 3. This is always going to be equal to your exponent because that's what we're looking for. So remember, you read it, log base 2 of 8 equals 3. That's how you read these. To the next one, log, your base stays first, so base 9. This has to be little, by the way, guys. You cannot write it the same size as the rest of the equation. Just like in an exponent, you cannot write an exponent the same size as the rest of the equation. It has to be little and up top. For a log, it has to be little and on bottom. This is required in order for it to be written correctly. So log base 9 of 3 equals 1/2. That's how you rewrite these. And then the last example, this is what exponential equation is really going to look like, where you don't know what your exponent is. That's why we need the log in the first place, is to solve for x. So I would write this as log base 4 of 64 equals x. Now I'm able to solve for x. I do want to show you how to do this in the calculator real quick. So if you're using one of the school calculators, if you hit math and then arrow up 3 times, you'll see log base. So for this one, I have log base 4 of 64, and the answer is 3. So you can put these right in your calculator, and it solves them for you, but you do have to rewrite them yourself. The calculator will not rewrite it for you. Okay. I also want to talk about natural logs. We use these when the base is e. We talked about e when we did growth and decay. Remember, e is a number with a value. It's that 2.71 number. So on your calculator, if you look, it's right here, it's second divide. So if I hit second divide, you'll see that E show up, and E has a value, that 2.718 number. So anytime your base is E, this is when you use a natural log, and natural log is written ln(x). Okay? So whatever you're looking at. So I'll do an example just to show you. So if you're given e to the x power equals 3, so this is an exponential function. I'm looking for x. E is my base. I would write this as the natural log of 3. On your calculator, that is also a button. If you look over here, there's a log button and a natural log button. This log button is always base 10. So if you ever see a log that doesn't have a base, it's automatically base 10, you use this button. But if it tells you the base, you're going to have to use that log base like we talked about. But here's ln, natural log of 3, and I get 1.098. So approximately 1.1. So anytime you see E, that means it's a natural log. You have to use the natural log button. And then I do want to write down, if you ever see, just going to make one up, log of, we'll say, let's make a number 4. Okay. If you don't see a base here, if it is missing, okay, that is automatically base 10. That's when you can use that log button. So if you do not see a base, it is automatically base 10. Alright, I want to do a couple more examples. Okay, what if you have a little bit more going on? So for example, we'll say 2 to the x plus 5 power minus 8 equals 10. Okay, so for this one, for example. So in order to solve for this, I want to solve for x. I need to be able to write it as a log. So I'm going to have to get the base of the exponent by itself, which means I need to move this 8 off. Once you get it down to just a base and an exponent, then you can write it as a log. So this one would read log base 2 of 18 equals x plus 5. Now I can put log base 2 of 18 in my calculator. It's going to give me this number, 4.17. So the last thing I just need to do is subtract 5. So I can take this number and hit minus 5, and I get negative 0.83. So if you have a little bit of extra stuff going on, you have a number behind it or maybe a number in front, you have to move those away first before you can write it as a log. Now you may also see problems that start off as logs. So one like this. Okay, now if we can write exponents as logs, that means we can also write logs as exponents. It goes back and forth. But in order to solve this, I need to get the log by itself. So the first thing I need to do is divide this 3 off. Now that I have the log with just a base and an argument, I can rewrite this as an exponent. So they're inverses of each other, which means exponents can be logs and can be written as logs, and logs can be written as exponents. We can go back and forth. So to write this as an exponent, it's 4, that's my base, to the 5th power equals x plus 1. This just got a whole lot easier to solve. So I can do 4 to the 5th power is 1024. And if I subtract that 1, 10,023. So no matter which way you see it, you can solve it. We'll do one more example, then we'll be done. I want to show you what it looks like if you have a log on both sides. So for instance, log of x minus 2 equals log of negative 3x minus 10. Okay? So this one has a log on both sides. When this happens, as long as your bases are the same, you can drop the logs. Now remember, if you do not see a base, it is automatically base 10. Please remember that. If you don't see a base, automatically base 10. These have the same, so I can ditch them entirely. I get x minus 2 equals negative 3x minus 10. This just becomes a simple equation. So I'm going to add 3x to the other side. I'm going to add 2. And then when I divide by 4, I get x equals negative 2. So these are the types of problems you're going to see when you work these out, when we go over the classwork.